Okay, section 7.2, just sample proportions. There's two formulas you need. Finding the mean of the sampling distribution of p hat and finding the standard deviation of the sampling distribution of p hat. That's it. So those are our two bullet points, but I'm going to write out in words what it means and then the formula. So basically this is the mean of the sampling distribution, the mean of the sampling distribution of p hats, the sample proportion, proportions is equal to, it's a very easy formula to remember, it's just equal to the population proportion. So hopefully you know now what that entire sentence means, and we can write it with this notation. This is the notation. The mean, and on the test I may just give you the notation. I might not even write the words. I may say find the mean of p hat, and I'll just write it like that, and you need to know what that means. Okay? That's the mean of the sampling distribution of p hat is equal to the population proportion. That's it. And then for standard deviation, I'm going to write it in words and then the equation, and especially when you go back and review, having it written out will help. The standard deviation now of the sampling distribution of p hat, of the sampling, I'll abbreviate distribution, sampling distribution of p hat is this. So this is how you write it. This is a symbol for standard deviation. Sigma sub p hat. Standard deviation of p hat equals the square root of p, which is the population proportion, times, in the video he said q, but q is just 1 minus p, or you could say like p naught. So if the population proportion is 25%, p is 0.25, this would be 0.75. And then you divide by n, which is the sample size, so you can see in the equation as n increases, the standard deviation decreases. And so just for you, for your notes, because you will forget what these mean, even in the equation, is that p, just make sure you know, means the population proportion in this equation, population proportion, and n is the sample size. You'll be able to do problems faster if you just memorize it, but it is on the formula sheet. And so, but the thing is that this formula only works as long as the 10% condition is true. So in other words, as long as you don't sample larger than 10% of your population size. Otherwise this formula won't work and you have to do something else. So as long as the 10% condition is true. It's like the condition for independence, because as you draw something out from a population, the probability is changing every single time. But as long as you don't take too big of a sample, it won't matter. It won't affect the answer enough. So as long as a 10% condition is true, so you have to check that, and we'll do that in the example. And then the last thing is that this distribution will be approximately normal if the normal condition. So there's a 10% condition and the normal condition. So you can only use a normal, this is the last bit, can use a normal approximation if and only if NP and N1 minus P are greater than 10. Which you might confuse with the 10% condition because it's 10 again, but it's not related. So if NP and N1 minus P are both greater than equal to 10. And I did show a video in chapter 6 on that happening with airline flights arriving on time, and I put the link in this folder, and I can show you again how that happens as long as those of greater than equal to 10, the shape of it, the distribution starts to look more normal.